Hello, welcome to the video. In this lesson, we're looking at section 11.5, where we're going to be making inferences from sample surveys. So by the end of this, we are going to be able to use sample surveys and able to infer a conclusion about a population. One of the first things that they want us to do in this section here is they wanted you to be able to estimate a mean of a population, and it usually dealt with when you're using relatively large numbers for a sample set. So in here it talks about 40 teenagers that use social networking. Um, in this case, this is the number of friends they have um, on their social media accounts. They say estimate, but you're really still doing the same things if you were just finding the mean itself. You're still going to be adding up all of the values in the sample. Okay, so if you add up, 281 plus 247 all the way down to 278, you get a result of 11,966. All right, so I encourage you to check that math, please. And you are going to divide it by the number of, uh, in this case, the number of teenagers. So there's 40 of them. All right, this equals, all right, 299.15, but the estimation comes at the very end. So about 299 friends are on these individuals' social media account as friends. Okay. The other thing that we're looking at is being able to estimate population proportions. So, excuse me, in this particular question, or in this particular example, it says a student newspaper wants to predict the winner of a city's mayoral election. Two candidates, A and B, are running for office. 8 staff members conduct surveys of randomly selected residents. The residents are asked whether they voted for candidate A, and the results are shown on the table. So if you look here, one individual talked to 5 people. 2 of them said they voted for candidate A, which then gave you a percentage. All right, and then someone else, oh, they surveyed 150 people, and then they said that 88 people uh, voted for candidate A. So again, it's just taking the number of people that voted for candidate A divided by the number of people that they surveyed, and that's where they get this percentage here at the end. Excuse me. So the first question that they ask here says, based on the results of the first 2 sample surveys, do you think candidate A will win the election, and explain? So the first 2 surveys. So the first 2 surveys are right here. And looking at those 2 surveys alone, uh, the answer would be no. All right, the answer would be no, and our explanation for that is since in each survey, both sample percentages are less than 50%. You need more than 50% to um, win an election. So that's where I would say since in each survey, um, candidate A has less than 50%. of the votes. Looking at example B here, it says, based on the results in the table, do you think candidate A will win the election? It says, explain. So what I would say is, as we increase the sample size, we get, so like I'm just going to use the largest sample size, which is in 200, and that gave us a 59% candidate A vote. So looking at the entire chart, I would say yes, since the largest survey number, or our largest survey size, we'll say, had candidate A with 59% of the votes. And since 59% is greater than 50%, I would say that he would have won the election based off of this survey. Another thing that we're going to uh, focus on is being able to do what is called analyzing population proportions. So in this example, it says that a national polling company claims that 34% of the US adults say mathematics is the most valuable school subject in their lives. You survey a random sample of 50 people, of 50 adults. It says, what can you conclude about the accuracy of the claim that the population proportion is a 0.34 when 15 adults in your survey say mathematics is the most valuable subject? So looking at your specific survey, of the 50 people that you surveyed, 15 of them said that mathematics was the most important subject. So if you were to detach that as a percentage like they did here in the polling company, so 15 over 30, or 15 over 50, I'm sorry, gives you 30%. Now, the question is 15% close to 34%, right? Yeah, it's pretty close. So since it's pretty close, you could make the claim that the companies, um, the polling companies claim is more than likely true. Also, looking here, it says, what can you conclude about an accuracy of the claim when 25 adults in your survey say mathematics is the most valuable subject? So here now, an entirely different survey said that had 25 of the 50, which gets you at 50%. All right. 50% is not that close to 34%. So if your survey gave you that number, you could make an argument that the polling companies claim is more than likely false. But what do you have to do? You have to, in order to show more validity, whether the claim is true or false of this polling company, you need to present more than just the one survey. So what the book shows, and um, what they're saying here. It says they want you to assume that the population proportion is, 34%. They want you to estimate the variations among the sample portions using samples of size 50. So what the book did was this. So they had a chart, which you can find on page 626. No, I'm sorry, 628. Page 628 in the textbook gives you this chart, okay? Now, here is all of these dots that are saying is this. So what they did is they did 80 surveys of 50 adults. So each dot represents one of the surveys of 50 adults and where the percentage landed on individuals choosing or adults choosing that mathematics was the most valuable school subject. So like this particular sample of 50 people said that 22% of them said that mathematics was the most important. So like you could say that this sample right here was comes from the example from A. And then this sample right here came from the sample set from B, okay? Now, there are different ways that you could actually create a random sample. So I'll show you how to do it on your graphing calculator. So if you take your graphing calculator and you go and click on math and then go scroll towards the PRB and then you go all the way down to number 5. All right, number 5 is it's going to select random integers. Okay, so when you click on that, it's going to prompt you um, to create 3 numbers. All right, so we are going to do integers from 0 to 99. So it's going to randomly choose numbers from 0 to 99. And since this was a sample set of 50, we're going to get 50 of them. All right, and then we're going to hit enter. So now we have 50 random numbers, okay, from 0 to 99. Now, what they're saying is that since the polling company gave us a 34% that mathematics was the most valuable subject, what we can use now is since we have 100 integers, 0 to 99, we could say from essentially one, we could pick any number we want. So like I'm going to pick numbers 1 through 34. All right, so any numbers that were 1 through 34 in this sample is going to be votes for mathematics. So like this number 14 right here, that's a vote for mathematics. You scroll down, 73, see, oh, I got a 4, that's a vote for mathematics. 33, that's a vote for mathematics. 99, no. 20, that's a vote. 79, nope. So 22 is a vote. 10's a vote. 54, no. So what you're going to do is you're going to go all the way and scroll through and make a list of which numbers came out of 1 through 34. And then you would like put that in like a spreadsheet or something like that. And then that's where they made these polls from. So now that whole process would take a lot of time. So thankfully they already have this simulation here that we can look at. So what they're saying here is that despite all of us would get different charts, all right? So like the bubbles would be in different spots. But essentially, if we go through enough samples, whether it's 60 samples, 70 samples, 80 samples like they did here, 90 or 100, whatever that might be, you will notice that the chart will look very, very similar to the chart that we have here in the notes. It's going to still be a bell curve that is symmetric. All right, so if you notice, it still kind of looks symmetric here. All right, that's good. What they want us to estimate here is the variation among the sample proportions using these 50 samples. So now what we can say is in a normal distribution, like we talked about earlier on in the chapter, we can say that 95% of the possible sample proportions will lie within two standard deviations of the mean. All right, we're saying that the mean is 34% or 0.34. So these red values here are considered to be like outliers. Those are part of the 5%, all right, not the 95%. So the range in this particular one looks like this one here is 0.2, and this one here is, I'm guessing, like 0.48. So my range is going to fall between 0.2 to 0.48, or 20% to 48%. All right. So anything in a survey that falls between 20% and 48% would fall into something that would be really close to the claim that this polling company made. All right, and then the final concept that we're going to look at in this section is talking about margin of error. All right, so margin of error, it says when a random sample of size n is taken from a large population, it gives you a margin of error, which is an approximate by plus or minus 1 divided by the square root of whatever the sample size is, which is n. So what we're going to look at is, it says here that in a survey of 2,048 people in the United States, 55% said that television is their main source of news. So the first portion of this is they want us to figure out what is the margin of error of this survey. So to find the margin of error, you're just going to say, okay, plus or minus 1 divided by the square root of the sample set, which is 2,048. Okay, so when I type that in, 1 divided by the square root of 2048, I get plus or minus 0.022. All right, so that's my margin of error, plus or minus 0.22. All right, so the second portion of this, it says give an interval that is likely to contain the exact percentage of all people that use television. So that means converting this to a decimal. So I'm going to say I got my 0.55, and I'm going to add 0.022, and I'm going to take 0.55 and subtract 0.022. So that's where the plus and minus come in. So this is what, 0.572, and then this is going to be 0.528. So to attach percentages to this, my intervals is going to fall between 52.8% and 57.2%. So due to the margin of error of this survey and whatever, and the size of the population, even though it says 55% in the chart, it could fall between 52.8% and 57.2% depending on the margin of error. And that is making inferences from sample surveys. I hope this helps. Until next time.